and welcome. We are going to expand now our discussion on examples on simple string. So perhaps we can start with the discussion on the stress and strain diagram. So let me have here the problem number 1. So the problem number 1, what force is required to punch a 20 millimeter diameter hole in a plate that is 25 millimeter thick? So we have here the shear strength is given to be 350 meganewton per square meter, or that is in megapascal. So a concrete cylinder having a diameter of 6 inches and a gauge length of 12 inches. So in other words, this is a cylindrical sample having a diameter of 6 inches and a length of 12 inches. So basically this is a compression test. The results of the test are reported in the table as load versus contraction. Draw the stress-strain diagram using scales of 1 inch equivalent to 0.5 ksi and the scale of 1 inch for a strain of 0.2 times 10 raised to negative 3. So the unit is basically inch per inch. From the diagram, determine approximately the modulus of elasticity. So as we can see here, so this is actually the given. So the load and the contraction is given. Of course, we all know that the load from the load sigma can be derived as well as the epsilon, or the simple strain could be derived out of the contraction. So all we need is to recall this formula: sigma is equal to P all over A, and that the strain is equal to delta all over L. So this problem basically obtain the solution out of the graphical method. So first, from this load and deformation, the strain and the stress was derived. So all of the values here were divided by the cross-sectional area of the cylindrical cylinder. So take note that we have here an area that is a circular area equivalent to pi all over 4 times diameter squared. So the diameter here is 6 inches. So this is the divisor for these values to come up with the stress. So the corresponding stresses are shown here, and then similarly this sigma is, or this epsilon is derived out of the contraction. So contraction here is actually, this is delta and that is P. So delta here, so all of the delta were divided by the length that is equivalent to 12 inches. So this is how epsilon was derived, and then we come up with these values. So following now our scale set by the problem, that we have a 1 inch equivalent to 0.5 ksi that is laid on the y-axis for the value of the sigma, and 1 inch is equal to 0.2 times 10 raised to negative 3 laid as an interval for the x-axis, or this is epsilon, or what we call simple strain. So those points are then graphed into those points. So the solution is more on graphical, in a sense that it finds the transition between the curve and the straight line. So this is the transition between the curve and straight line. So how was it done? Basically, it just established straight line from the point of origin up to the point where the transition is. So as we can see, if we are going to project that one, some points aren't coinciding with the straight line. That is why this is obtained by graphical method. So basically, this is an approximate approach wherein sigma is projected horizontally and obtained a value equivalent to 1.31, and this point is again vertically projected downwards so that it will obtain a value of 0.004 value. So I would like to reiterate that in some board exam problem, if we encounter this type of problem, it is just enough that we are going to use the delta, or the change in the strain, as well as the change in the stress. So how is that done? Basically, we have here a straight line, or in short, we have a proportionate relationship between sigma and epsilon. So what we do is to take advantage of that geometry. So as usual, if we have a straight line, we usually look into the triangle. So here is a point wherein we can use that slope. So I'll just pick 2 points here in order to establish this triangle, and basically this triangle is similar to any of the triangle in this straight line. So if we try to investigate the dimensions here, so this projection is obtained out of this point and out of this point. So basically, this dimension here is the difference on the vertical side. Say if we have here a dimension for, or an ordinate for sigma as well as epsilon, we also have an ordinate for sigma and epsilon at any point on this curve. So therefore, we'll just get the difference of that. See, this is delta sigma, and the x dimension for this triangle is actually delta epsilon. So we can also do this in series of points. Just choose 2 points and then just deduct the difference between them, so that the solution would be that the modulus of elasticity is equal to the delta sigma all over delta E. Now, delta sigma all over delta epsilon could be the difference between the two stresses. Similarly, this is the difference between the two strains, in which you could apply. What is important, you have 2 points. In order to establish this one, you could apply within this straight line. But the danger here is, do not pick points that is within the edge or within this curve. So that is the key here. So in problems in board exam, basically you are going to choose, or you may opt to graph it to make sure the straight line, and then pick 2 points on this straight line, but not on the beyond the proportional limit. So that is an acceptable solution. But in here, as we have said a while ago, some points did not meet the straight line, so it's hard to establish the straight line here. So we're going to opt to approximate the fracture line or the boundary between the straight line and the curve line. So as a solution, the solution here is equal to the obtained sigma all over the obtained approximate values for sigma and epsilon. So basically we have come up with a value equivalent to 1.31 all over 0.004. So let me check. We have here 3.275 times 10 raised to 3 KSI. 3.275 times 10 raised to 3 KSI. So 3.275 times 10 raised to 3 KSI. Okay, so this is the answer for this problem. So again, I would like to reiterate that this could be done by a geometrical principle, or this solution in particular was directed towards a solution in a more on graphical method, because it has set a certain distances for you to graph. Okay, so that's it for the problem. So stand by for the next problem on string. So thank you.